Okay, so for number 6. All right. So in order to find this limit, obviously if you plug in -3, you're going to end up with 0 in that denominator, which you don't want. So we're going to need to find a way of simplifying this. Whenever you have, this is called a complex fraction, which is mainly this whole thing is a fraction, but then you have these fractions here. Start off with this piece here in the denominator. So we have 1 over 3 plus x minus 1 over 3. You need to be able to subtract these. The common denominator here would be 3 plus x times 3. You get what I mean? So I'm going to multiply this denominator here by 3. So I have to multiply the numerator by 3. And then here I have to multiply this by 3 plus x. So 3 plus x. So far, so good? Okay. So in the numerator, what you have is 3 times 1, so 3, minus, and then you have 1 times 3 plus x, which is 3 plus x, but it's minus that. So think about distributing the negative. So this would be minus 3 minus x, all over 3 times 3 plus x. Is that good so far? Okay, these 3's here obviously cancel. So what we're left with in the denominator for this whole thing is negative x over 3 times 3 plus x. That's my new denominator instead of all of this. So we have x over negative x over 3 times 3 plus x. Okay. So now we're going to copy, change, flip. So I have this divided by this. So I'm going to copy x, change to multiplication, and flip this. So it's going to be 3 times 3 plus x over negative x, which my x's here would cancel out. So I'm left with 3 times 3 plus x over negative 1, which will just make the whole thing negative. Now that I've canceled everything that I could, we're going to plug in the -3. But when you plug in -3, you get -3 times 3 minus 3, which would give you 0. Okay. 13? Yeah. Okay. So whenever we did absolute value limits, but I know it's been a while, but whenever you have an absolute value, you have to rewrite the absolute value part as the piecewise function. So if it's positive x, then that's going to be for when x is greater than or equal to 0. So how do we write the piecewise function? You always first remove the absolute value, keep it as is, and make it for when x is greater than or equal to 0. And then you do the negative version, so negative x, which will be for when x is less than 0. So the positive version is always greater than or equal to, and then the negative version is less than. Okay, so we have to look at the direction. If it's both, you have to do both. Well, like if it's a general limit, but it's the left-handed limit, which is the bottom one here. So we would do the limit as x approaches 0 from the left. Instead of absolute value, I'm going to replace it with the left side, which is negative x over x. Wait, Caitlin seems to be having issues logging in. Okay, so here my x's would cancel, and then I'm left with -1, and there's nothing to plug in, so this would be my answer. Mm. Yeah, 29. And I can go back and forth if you still had limit questions or whatever. See number 27, 28, 29. Okay. This is finding the derivative. Yeah. Okay. So before we can take this derivative, you have to rewrite it so that it's all of our exponents are in the numerator, as well as any radicals written with the rational exponent. So this is equivalent to y equals 8x to the 6 minus 5, and then this is x to the 1/4 plus 2, and then I'm going to bring this up, so this is going to be x to the negative 3. Okay, now we're ready to take the derivative. So y prime is going to equal to 48 x to the 5th minus, now I'm going to multiply 1/4 with 5, so 5 over 4 x, subtract 1, so I'm going to subtract 4 over 4, which would be negative 3 over 4. And then negative 3 times 2 would be negative 6. X, subtract 1, so negative 3 minus 1 is negative 4. And you can leave your answer like this if you want to write it a little bit nicer without any negative exponents. An equivalent answer would be 48x to the 5th minus 5 over 4x to the 3 over 4 minus 6 over x to the 4th. What else? 54 and 56. Okay. Are those related rates? Is that why you're shaking? Okay. Okay. So this is not related rates. This is actually optimization because it's asking for the least amount of material. So whenever you see this wording, least amount of any material, that's always you're minimizing the surface area of this, whatever this is. So I'm going to draw a picture. We have a cylindrical can, okay, that will hold a volume of 1,000 centimeters cubed. And, oh, and we're looking for what is the radius, okay, with the least amount of material. So that would mean that we're minimizing the surface area of a cylinder. So, you know, a lot of these formulas we don't have, so we need to remember how to get surface area of any shape. If it's a cylinder, the top and the bottom surfaces are circles. And since there's two of them, that's going to be 2 pi r squared. Because remember, pi r squared is the area of a circle. Is that good so far? Okay. Plus, now the area of this, like that wraps around, think about like any label around a can. If you unwrap that, what you get is a rectangle. Now the rectangle, right? The base of the rectangle is the part that wraps around the cylinder, which is the circumference around the circle. So that's 2 pi r. And then the height of the rectangle is just the height of the entire cylinder. So I'm going to add this area, which is 2 pi r times h. Does that equation make sense? Okay. So since that's what I want to minimize, now I have a problem because we have here too many variables. We're trying to solve for r. So what we're going to do is take the volume equation because they give us volume for a reason. This is, you said 54, right? Sorry, I'm just making sure that everything so far is on track. Okay. The volume of a cylinder is pi r squared times the height. So far, so good? Okay. What I'm going to do is I'm going to use this equation here to solve for h. Because if I solve for h, then what I end up with is an equation that has r. You get what I mean? So I'm going to divide by pi r squared on both sides. So I get here that my height is equal to 1000 over pi r squared. Also, it makes sense to solve for h rather than r, because if you solve for r, you're going to have to square root, and it's going to be really annoying. Or is this okay so far? Yeah. No, no. Andres, you had a question? Oh, okay. Sorry, I thought I heard you say something. Okay. So we're going to take this. This is h, and we're going to plug it in here for h. So 2, this is for A, my area, 2 pi r squared plus 2 pi r times the 1000 over pi r squared. So here the pi's would cancel, and one of these radius will cancel as well. So my equation for area is now 2 pi r squared, and then I have this 2 times 1000, so that'll be plus 2000. And then I'm going to bring the R up, because whenever you're doing any kind of optimization, you want to take the derivative, since we want to minimize. And anytime you're minimizing, maximizing, that's always the first derivative. Up to here is okay? Okay. Now we're ready to take the derivative. So all of that was just to prepare our equation so we can actually get the derivative. So A prime is going to equal to 4 pi r minus 2000 r to the negative 2. And we're going to make it equal to 0, because to find the location of any minimum or maximum, that's where we're looking for our critical numbers. Okay? So let me rewrite this one more time so we no longer have this negative exponent. So 4 pi r minus 2000 over r squared. Okay? Now you have several ways of going from here. We want to solve for r. So we can, if you want to, no, let's go with this one way because I think it's easier. We want to get rid of this fraction so we don't have to deal with having r in the denominator. So what you can do to cancel that out is we're going to multiply the entire equation by r squared. Because if I distribute it, it's going to cancel out here. Do you get what I mean? So 4 pi, and then it's r times r squared, so r to the third, minus 2000, and then the r squared will cancel, is equal to 0 times r squared, which is still 0. Add the 2000, so 4 pi r cubed is equal to 2000. Divide the 4. Oh, and the pi, might as well. Cancel that out. So r cubed is going to equal to, what's it called? 2000 divided by 4 is 500 over pi. Then you cube root it. So r is equal to the cube root of 500 over pi. I know it says that you have to find the minimum, right? If you ever are doing an optimization question where you only end up with one critical number, like we do here, because this is only one critical number, you don't have to test it. That's going to be your answer. If you end up with more than one critical number, then you'll want to put it on the number line and check to see which one goes from, in this case, negative to positive, because that would be your minimum. But if there's only one number, that's it. Don't waste time. Is this one okay? And then you said 56, right? Okay. Okay, so this one is a related rates. A person that is 2 meters tall walks directly away from a street light that is 8 meters above the ground. Okay, so I'm going to start drawing a picture. So this is the street light. This is 8 meters, whatever. Here is the person that is 2 meters walking away from the street light. So going this way. Okay. If the person is walking at a constant rate and the person's shadow is lengthening at a rate of 4/9 meters per second, at what rate in meters per second is the person walking? Whenever you get an example like this of a street light or a lamp or whatever, or a building, and then like a person that's walking away, what this is going to do is it's going to create a triangle. A triangle within a triangle. You have this big one here and then the little one here. So since the light is behind, this is the shadow here on behind the person. Or wait, just kidding. Is that how I have it? I have it different on the answer key, so I want to keep it like the answer key. You know what I mean? So that way I don't confuse you. I have so that the shadow is here. Yeah, that makes more sense. And then the person is walking this way. And then this is the person's shadow. Is this okay? Okay, so this we know is 2, this is 8, and then we also know the shadow is lengthening. So I'm going to label these two sides here because this is the rate at which the person is walking, so I'll call that x, and then this is the shadow, so I'll call that y. So what we're given is dy dt. Remember, because it's this is our actual rate, which is 4/9 meters per second. Just going to underline my units there. So what we're looking for is dx dt. Is that okay? Okay. When you have a triangle within a triangle and they are right triangles, which they are, these are similar triangles, meaning that their sides are going to be proportional to each other. So you can set it up however you want, small to big, big to small, as long as you're consistent. Let's say if I do small to big, and you can draw them separately if it makes it easier. So like, for example, if this is my small one, right? So this one here, this is 2, and this is y. And then my big one, right? This is the 8, and then this entire length, this is x and y. So it would be x plus y. Is that clear? So I'm going to go small to big. So corresponding sides go together. So the 2 goes with the 8. So this is 2/8 is going to equal to, and then these are my corresponding sides. So y over x plus y. So we have a ratio. Once you have your ratio set up, how do we solve this? What do you think I'm going to do? When you have a fraction equals to another fraction. cross multiply. Exactly. Whenever you see this, right? Because the next step would be to take the derivative, but this is going to be really annoying because we have the quotient rule. So we don't want to do that. So we're going to cross multiply so that way we don't have to use the quotient rule. So 2 times x plus y is going to be 2x plus 2y because you would distribute the 2. And that's going to equal to 8y. You can also combine the y's, right? I can subtract this 2y over. So 2x is going to equal to 6y. Now I can take the derivative much more easier, whatever, you know what I'm saying. So this would be 2 dx dt is going to equal to 6 dy dt. We have the dy dt, so we're going to plug that in. So this is 2 dx dt is going to equal to 6 times 4 over 9. Which 6 times 4 over 9, we can simplify the 6 over 9 by 3. So this would be 2, this would be 3. So this equals to 8 over, oh my God. Okay, what did we leave off? Oh, here we simplified. Okay, yeah, so then 2 times 4 is 8 over 3. And then to solve for dx dt, which is what I need, we would divide everything by 2. So divide by 2 here. And then dividing 2 is multiplying 1/2. So then dx dt is going to equal to 8 over 6, which these can be simplified here by 2. So this would be 4 over 3. And then our units, which would be meters per second. Shut up. Okay. So that's 54 and 56. What else? 60. Yes. This is, oh, to integrate. Okay. So when we're integrating this, you can't integrate when you have a fraction like that, or at least not yet. So what we're going to do is we're going to rewrite it. So this is the integral of x squared minus x plus 4 over x to the 1/3 dx, right? Think about it as simplifying your fractions. You can separate each one of these. So this is x squared over x to the 1/3 minus x over x to the 1/3 plus 4 over x to the 1/3. So far, so good? Okay. We want to simplify all of these individual fractions. So x squared, here we would need to subtract. So I'm going to put this over 3. So multiply this by 3. So that's x raised to the 6 over 3 over x to the 1/3 minus x 3 over 3 over x to the 1/3. And then this one is the same. Is at least this part okay? All right, and now we're going to simplify by subtracting all of those exponents. So 6 over 3 minus 1 over 3 is x to the 5 over 3 minus 3 over 3 1/3 would be x 2 over 3 and then plus 4x to the negative 1 over 3. So that's what I'm going to be integrating, x to the 5/3 minus x to the 2/3 plus 4x to the negative 1/3. So for all of these, we need to add 1 and then divide by the new exponent. So I'm going to add, they all are over 3, so I'm going to add 3 over 3 to each one. So this is going to be x to the 8 over 3. And then we need to divide by the new exponent, which dividing by 8 over 3 is multiplying the reciprocal. So we're going to put 3 over 8. Minus x to the 2/3 plus 3 over 3 will be 5 over 3. And then divide by 5 over 3 is multiplying 3 over 5. Minus, oh, sorry, plus 4x, and then adding negative 1/3 plus over 3 is 2/3, and then multiply by the new exponent, which is 3 over 2 plus c. And then the only thing that we're going to do here is simplify this. 4 times 3 over 2. 4 divided by 2 is 2. So this, my final answer would be 3x to the 8 over 3 over 8 minus 3x to the 5 over 3 over 5 plus 2 times 3, which is 6, x to the 2/3, and then of course the plus c. Okay. Yeah. So for 59, you're going to have to actually distribute this. So let's do that up here. So we have square root of x plus 2 over square root of x. And since it's squared, I'm going to multiply it with itself. Okay. So we're going to distribute. Square root of x times the square root of x is x. Then square root of x times 2 over the square root of x. The square root of x's would end up canceling, so it'll be plus 2. Is that okay? Okay. Then we distribute the 2 square root of x. So 2 square root of x over square root of x times the square root of x. The square roots would cancel, so we plus another 2. And then here, 2 square root of x times 2 square root of x would be plus 4 over, and then square root of x times the square root of x, which would be x. So this is what I get when I distribute, which would be the integral of x plus 4 over x dx. This thing needs to stop messing with me. Okay. So now we integrate, add 1 to the exponent, so this would be x squared over 2 plus 4x plus, then this is 4 over x, which is the same thing as saying 4x to the negative 1. So if I add 1 to that, I get 0. And then if I try to divide by 0, you can't divide by 0. So remember that if that happens, that's always your ln function. So this would be plus 4, because this is just a coefficient, ln x, and then the plus c. Yes. Yeah. Or let's say if you have like 2x over x squared. This is also ln. I mean, you can simplify it, right? Which would be 2 over x. So again, you should recognize that as ln. Or you can also say, oh, 2x is the derivative of x squared. So this is the same thing as the ln of x squared. So both of these actually mean the exact same thing. ln of x squared and 2 ln x are the same because for the rules of ln or logarithms or whatever, any exponent can be moved to the front. So ln of x squared is equivalent to 2 ln x. Okay. What else? 36 and 38. What am I doing here? Oh, this is a derivative, right? Okay, so this is implicit since you see how you have y not by itself. So whenever you take the derivative, you just take it like normal, like y squared would be 2y, but then we're always going to multiply by dy dx. Plus, then x, e, y, this is a product. So we're going to have to use the product rule because you have x and then times e raised to the exponent of y. So the derivative of x is 1, so it'd be e raised to the y plus x and then e raised to the exponent of y and then the derivative of the exponent, which would be dy dx, equals to derivative of 4 is 0 and the derivative of negative x is negative 1. So we want to keep all of the dy dx's on one side, but we're going to move everything else over to the right. So I'm going to subtract this e to the y over to the other side. So we got here, this is all that's left, which has the dy dx. So we can take out the dy dx, and what we have left would be the 2y plus, and then the x, e, oops, not that. X e raised to the y is equal to negative 1 minus e to the y. Is that clear so far? And then divide. That's your final step. So dy dx is going to equal to negative 1 minus e to the y over 2y plus x e to the y. That is 36. And then 38, this is an exponential function where your base is not e. So the derivative of anything like this is going to be the ln of your base, which in the notes I called it a, so I'm going to be consistent, times the exponential function itself, a raised to whatever the exponent is, and then times the derivative of, oops, the exponent. So my base is 3. So y prime is going to be the ln of 3 times, we leave the exponential alone, so 3 times 2x squared plus 1 times the derivative of the exponent, which is 4x. And that's basically your answer. If you want to write it a little cleaner, you can always move the 4x to the front times the ln of 3 and then times the exponential. Okay. Andres, do you have any more? Okay. Okay, so then we'll call it. Thank you guys for sticking through to the end. I know that it was kind of a pain in the butt. I'll upload this so you can let Kaylin know that her questions, are answered. If you guys have any additional questions, by the time we start school, but you want to turn it in on Tuesday, for um, what's it called, for this quarter, you can always come by after school on Monday and we'll review. Okay? All right, guys, enjoy the rest of your break.